Okay, let's talk about what we're saying here is your first convergence test for series, but it's actually your fourth because we talked about geometric series, and we know that geometric series converge when the absolute value of r is less than 1. We talked about telescoping series, and we know that telescoping series converge when we can find a limit as n goes to infinity after we've done partial fraction decomposition. And we've talked about p-series, and we know that p-series converge where p is greater than 1. So this next test is called the nth term test for divergence, and like its name says, it can only tell us whether or not a series diverges. It cannot conclude on convergence. So it basically says that if we have a series where a sub n is the underlying sequence, if we can take the limit of the underlying sequence and find out that the limit is not 0, then we know that that series must diverge. The converse is not necessarily true, meaning if the limit of the underlying series or underlying sequence is equal to 0, this test is inconclusive. So it says here, just because the limit equals 0, convergence is not guaranteed. And we can prove that using the p-series that we talked about. For example, the limit of 1 over n as n goes to infinity is 0, but we know that the harmonic p-series is divergent. But we also know that the limit as n approaches infinity of 1 over n squared is 0, and we know that this series is convergent. So I've just shown you two examples where the limit is 0, and we have differing conclusions, which again shows that this test does not show convergence, it only can prove divergence. So we have two examples here, and these are used frequently with rational functions, and so you think about the expression n squared over 5n squared plus 4, and you're taking the limit as n goes to infinity. Well, you have the same degree in the top and the bottom, so your ratio of leading coefficients is 1/5, and 1/5 is not equal to 0, and therefore this series is divergent. Next, we have n over n cubed plus 1. And the limit as n approaches infinity of n over n cubed plus 1 is going to equal 0 because the numerator has a smaller degree than the denominator. So that when we graph this function, it has a horizontal asymptote on the x-axis. So this test is inconclusive, and we will eventually teach you different tests that you can use to determine whether this series converges or not.